This is Sprite Engine. Welcome. Hopefully this tutorial is the first one of many. My intentions are to keep these videos short and relevant, so they can function as a quick reference guide and get you going as quickly as possible. Okay, so let's jump right in. In this tutorial we're going to start from scratch and set up the player with all the necessary components. But first, before we do anything, we need to make sure the scene contains a world manager or else the engine will not work. Create an empty game object and add its component. The world manager is mainly responsible for running the scripts in order and other important functions like resetting the game. There must always be only one of these in the scene, and this game object must never be destroyed or disabled. Next, we're going to create the player. Add another empty game object and also add the Sprite Engine component. This is a powerful tool for creating sprites and animation states. We will rename the default sprite to idle, lock the inspector, and then drag and drop the necessary sprites from the project into the drop area. Once the sprites are set, you can move the slider to change the animation speed, and you can play the sprite in the inspector and in the scene. We will repeat this process to create the run, jump up, and jump down sprites. To create a new sprite, simply click the Add button. It's also possible to change the background color of the sprite preview area. You can also zoom in and drag the sprite. If you want to reset the preview area, simply right-click on it. Now we're going to add the player component to the player, which contains all the player abilities and inputs. This component requires a box collider 2D to work correctly. You must also add a rigid body 2D to keep Unity happy. Set its type to kinematic. The system will create several inputs for movement and jumping by default. These inputs are scriptable objects, and in the latest version of the engine, they can also interface with the new input system in Unity. The priority setting helps ensure abilities don't interfere with each other by assigning priority to each ability. Next, we have the collision settings. We won't worry about this right now, we will simply accept the default settings. And by default, the walk ability is always enabled. At the bottom, click the Add button to add abilities. We'll go ahead and add the jump ability. Now we create a ground object for the player to stand on. Create the game object, add a sprite renderer and a box collider 2D, and make the collision area wide enough. Next, the engine is expecting every solid surface a character interacts with to exist on the world or platform layers. World is for ground, slopes, walls, and ceilings. Platform is meant to be used for moving platforms. These layers are created automatically when the world manager was added into the scene. We set the ground layer to world. If we go into play mode, we can see the players colliding with the ground as expected. If we press the space key, the player will jump due to the jumping ability. However, it's immediately noticeable that the sprites that we set aren't working, and that's because we still haven't configured the sprite state. We'll go into Sprite Engine to fix this. First, we open the Signals foldout. Signals are basically animation signals that are set internally by the engine and are read by Sprite Engine to set the animation state. A list of all the signals in the system are included by default. Click on the relevant ones to enable them. We will enable all the velocity, ground, and jumping signals to work with. We open Sprite State and add two states by clicking the Add button. The signals we just enabled will now be available to use. For our first state, we set the signal to on ground and then add two substates. For the first substate, we set the signal to val x, which means the velocity in the x direction is a non-zero number. If this condition is true, we set the run sprite. For the second substate, we set val x 0, which means the x velocity is 0. If this condition is true, we set the idle sprite. We configure the jumping state in a similar fashion. If val y up is true, we set the jump up sprite. If val y down is true, we set the jump down sprite. These states will execute from top to bottom. If we go into play mode, we can see the sprites are changing according to the state of the player's velocity and collision state. However, if the player changes direction, we see the sprites have not flipped direction. Let's go back into Sprite Engine to fix this. First, we will enable the always true signal, which means, well, the signal is always true. We go into the blue state, which is responsible for flipping the direction of the sprite in its x or y axis. We set the signal to always true and create two substates. If val x left is true, we flip the sprite left. If val x right is true, we flip the sprite right. If we go into play mode, we can see the sprites are now flipping correctly. Let's now add Sapphire 2D camera to the main camera so it can follow the player. Once the component is attached, we will drag the player's transform to set it as a target reference. We will change the smooth value so that the camera follows the player with a smoothing effect. We change the offset to a 1 in the y direction so the camera is not following the player's feet. And we will add a dead zone, which is the area in which the camera cannot detect player movement. We will leave the other modules alone for now. We'll go into play mode once again and see the new changes. The camera is now following the player. That's it for this tutorial. Hopefully it helped in some way. If you have any questions, please let me know in the comment section and I'll do my best to answer you guys. For the next tutorial, I'm going to focus on some basic AI. Thanks for watching and see you in the next one.